Hey guys, hello everyone, welcome back, welcome to Vedantu's JEE channel. How are you all? Well, a special shout out to guys who are preparing for JEE for the next year. Yes, I'm speaking to people who are moving from 11th standard to 12th standard. So guys who are the one who are targeting JEE 2021, you know that this is a series which is specifically we are running for students who are moving from 11th to 12th standard. We can also call them the new 11th new 12th standard. Okay, so guys, here I am back again with a session where we are only going to solve MCQs related to things that we have studied in previous two sessions, and those are electric field due to objects and the potential energy, and you can say the electric potential as well. Okay, so I know that there are many students who are here for the first time on the channel. So let me start off with my own introduction. Yeah. So people, this is me, your Suri Sir, also known as Mugambo. Why? Because when you will crack the examination of J in future, Mugambo khush hoga. Yes. And not just me, there are two more awesome teachers who are there to take you through this journey for this year till the time you appear for your JEE examination in 2021. So guys, this handsome man is Harsh Sir. He is your chemistry teacher, and yes, this amazing personality is your maths teacher Arvind Sir. Okay, and yes, this ordinary person also will try to guide you through physics. More importantly, the timetable. So guys, I want you people to take a note of timings: 8 p.m. and 9 p.m. On 8 p.m., that too specifically on Monday like today, on Wednesday, and on Thursdays. What is going to happen? You are going to have MCQ sessions. Okay, and what I want you people to remember, even more importantly than that, are your theory sessions, which are going to happen every day on 9 p.m. Monday and Thursday at 9 p.m. you will meet Harsh Sir for chemistry. Wednesday and Saturday you will meet me for physics, and on Tuesdays and Friday you will meet Arvind Sir for mathematics. Okay, guys. So I hope it's very simple for you to keep in mind that every day 9 p.m. you have to be on this channel, and on Monday, Wednesday, and Thursday 8 p.m. you have to be on the channel to discuss MCQs as you are here today. Okay, and not just this, guys. If you are really serious about your preparation for JEE 2021, then during this lockdown also you can continue your preparation not just through the YouTube but also on Vedantu's platform. Yes, people, the enrollment is free of cost for the batch of 2021. And what are you getting here? You are getting 2500 plus hours of live online teaching with 45 plus amazing master teachers, and with 750 tests, 3000 assignments, and instant doubt solving, with possibility if you miss out on any lecture you can watch the replays and recordings and many more things, guys. So you understand that not just coming on YouTube, you can also be with us, not just three of us, you can be with all the master teachers, you can get your doubts solved, you can continue your journey. Doesn't matter for how long we are in lockdown, we can continue our JEE dream. Okay, and for people who are here on the channel for the first time, yes people, do subscribe to the channel right now. Reason being, just by subscribing to the channel you are going to ensure that your preparation is continuing, and all the notifications which are related to your JEE preparation, whatever videos of your academics as well as any motivational video that we do, you will be the first one to be notified. Okay people, so make sure that you are subscribing to the channel. Not just that, press that bell icon as well. Okay, so guys, here we are. Let's start our MCQ discussions on electric field as well as electric potential and electric potential energy. Okay, people. So here we go. The very first question, and as a matter of habit, let me change the color that I prefer most. Okay, so Electric potential at some point in space is 0, then at that point what are the options which are telling us? We have to answer it as our very first MCQ. So electric potential at some point is 0, guys. So what does that mean? Electric intensity, which means electric field intensity, is it necessarily 0? Is it necessarily non-zero? It may or may not be 0, or it is necessarily infinite. Tell me, what do you think is the correct answer? Hmm? Well, guys, if you remember, if you attended my previous session where I spoke about electric potential in lengths, I told you people that electric potential is nothing but work done. As simple as that. And what is electric field? It is nothing but a force. So you know that when we talk about work done is nothing but the dot product of force and displacement. So think of potential as work and think of electric field as force. Now you tell me, if your work done value is given to be 0, does that mean that force acting on the body has to be 0? Yeah, it may be, it may not be. For work to be 0, either the force has to be 0, or the displacement that is covered by the body has to be 0, or the angle between force and displacement has to be 90 degree. So one of the possibility could be there. That means what? You can see that either the force or you can say the electric field, it may be 0, it may not be 0. As simple as that. Okay. Next one, people. So this question says that on moving a charge of 20 coulomb by 2 centimeter, 2 joules of work is done. The potential difference between these points is going to be how much? That's what we have to find out. And by the way, this is a question from JEE 2020, sorry, JEE not 2020, JEE 2002. Okay, so if we say that we define the potential as work done per unit charge, then both the informations are very simply given to us. Work done is given to us as 2 joules and the value of charge is also given as 20 coulomb. Okay, a big charge. That means it is 1 by 10 volts, or you can say it is simply zero point 0.1 volts. Okay, guys. So the potential difference comes out to be very simply as option A. So yes, JEE is an exam where you will find easy questions as well. That's one way of looking at it. Okay, awesome. Now, next question, guys. Try to solve along with me. An electron of mass m and charge E is accelerated from rest through a potential difference V in vacuum. So the final speed of the electron will be how much? Okay, guys. So here it says that there is a charge which has been accelerated through a potential difference and there is some change in the speed which is happening. That simply means that the charge is going to gain some kinetic energy, and if the charge is going to gain some kinetic energy, then there must have been some work being done. So can I say that from work energy theorem we still remember that work done is equal to the change in kinetic energy. Okay, and if we want to bring potential in the picture, then we know that work done per unit charge, that means change in kinetic energy per unit charge, is nothing but your potential difference. Yes or no, guys? We can say that. That means the change in kinetic energy is nothing but Q into V. And because the charge is being accelerated from rest, it starts moving from rest. That means I can say that the final kinetic energy is half mv square and the initial one was 0, which is equal to E into V, because your charge is nothing but electron. That means from rearrangement of this, I get V square as 2 times E into capital V and divided by M. That means V comes out to be under root of 2 EV by M. Okay, let's have a look at the options. So option C is the one that looks like the correct answer. By the way, you can think of answering this from dimensional analysis as well. And by that, option A and D are definitely not the answer, but option B and C both are dimensionally correct. So we'll have to go by the religious approach of finding the answer. Okay. Okay, guys. Next one. Now this one says that a ring of radius r has a charge distribution of minus q distributed uniformly over it. So we have to calculate the charge that should be placed at the center of the ring such that the electric field becomes 0 at a point on the axis of the ring at a distance r from the center of the ring. Now honestly, guys, I do not remember what the expression of the electric field on the axis of the ring was. So definitely I'll have to look into that. So if I first focus on the ring itself, which is carrying a charge of minus q. So if I say that radius of the ring is r and at a distance r from it, say there exists this point P. Okay. So at this point P, if I try to join this line, definitely if this is r and this is r, this will be root 2 r, the hypotenuse. Then all the charge of this ring, if I divide that into small charge dq, then every dq charge is basically at a distance root 2 r from it. And eventually, as much as I remember, if I consider this angle is theta, then this will be theta. So this is going to effectively be the value of dE cos theta, and we got the value of the net electric field as integral of dE cos theta. I hope you guys are following me. Okay, so if I write the value of dE, that is k dq by r square, which is root 2 r the square. And what is cos theta in this triangle, guys? So in this triangle, cos theta is adjacent upon hypotenuse, that is r upon root 2 r. So this r and r gets cancelled, guys. So we have k divided by 2 root 2 r cubed. Yeah, and no, r got cancelled. It's not r cube, it's basically r square only. So this is going to be r square, because this r and this r got cancelled, and integral of dq. So from 0 to capital Q, eventually I get the value of electric field as kq by 2 root 2 r square. Okay, now this is basically the electric field due to your charge which is on the ring. Now you want to place a charge, say small q here. Okay, and you know that because the ring has negative charge, by the way, so the direction of electric field that I've drawn is actually going to be opposite. Doesn't matter magnitude wise. So definitely your q charge is going to be positive, and we have any which way considered a magnitude here. So all the options are any which way saying that positive options are there. So this charge is at a distance r from point P. So the electric field of that should be able to counterbalance, so that at that point the electric field becomes 0. And if I write the electric field because of small q charge, then it is k small q, and it is at a distance r square. So what do you see? K and k get cancelled, r square and r square get cancelled. This gives me the value of small q as capital Q by 2 root 2, which is nothing but option C. Okay, guys, I hope you are getting this. All we did was, if you remember the expression because of a ring, then it will obviously be even more shorter of a question. But as I always say, that I do not prefer memorizing unnecessary expressions, so it's easier to derive. So I derived it, and then the value of electric field at point P due to ring was balanced by the electric field due to charge small q. Okay, and we got the answer. Okay, guys, awesome. So moving on, next question is, we have a ring whose radius is given to us. Okay, so say that radius is r, and it has a very small gap which is 0.002 pi meter, means of the order of millimeters the gap is. And if the ring carries a charge of 1 coulomb, if the ring already has a charge of 1 coulomb, then the electric field at the center is going to be how much? So guys, it's basically a very conceptual question, more than the mathematics that I'm going to do in this question. See what happens when you have a very small opening here. It's actually the diagram that is being drawn in order to show you the visibility of the gap. Otherwise, we are talking about a very narrow gap. Okay, such that the charge which is there is, say, small q, and the gap is, say, L. Okay, now if I fill this gap with a charge which is of same charge density, can I say that the entire ring will be formed, and entire ring with entire uniform charge, say the charge density lambda, will be formed? And when a ring has uniform charge distributed over its periphery, then the electric field at the center will come out to be 0, because each and every point on the diameter will try to exert the same amount of electric field, and a diametric opposite point will do the same in the opposite direction. So that's why the net electric field at the center is 0. You are aware about that. Okay. So that means right now, if I just consider this charge and I find out the value of it, the magnitude, then finding the electric field because of this charge, considering it to be a point charge because it's a very small gap, that electric field is going to be equal in terms of the magnitude of the rest of the charge which is available in the ring. Yeah, so that the net electric field theoretically can become 0. I hope you got the idea. Okay, so let me first try to find out the value of the charge by equating the charge density. So in order to do that, I'll consider that the ring is almost already completed. So it has some charge capital Q and the length of the ring is 2 pi r, and the small portion which has been removed is small q and has a length L. Okay, small length L. Okay. Now what, guys? So capital Q is given to us as 1 coulomb. This is 2 pi and the radius is 0.5, that means 1 by 2, half a meter. Small q is unknown and the gap is given to us as 0.002 pi. So you can see that this 2 get cancelled with the other 2 and this pi gets cancelled with this pi. So the value of charge of that small section missing means if I have to put a charge over there to make the net electric field at the center 0, that charge comes out to be 0.002, or you can say it is 2 into 10 to the power minus 3 coulomb. Now all I have to do is find out the electric field because of this charge, which is kq by r square, because it is also at the same distance r. Okay, so q value, as you all know, is 9 into 10 to the power 9. Sorry, k value, and q is 2 into 10 to the power minus 3. We just found that, and the radius square is 1 by 2. Square that, so it is 1 by 4. So what do I have? This 4 goes up, becomes 8, and 8 nines are 72. So 72 into 10 to the power, this is 9, this is minus 3, so this is 6. So I think the answer is 7.2 into 10 to the power 7 Newton per coulomb. That's basically your electric field, and I hope we have an option. Yes, we have option B, 7.2 into 10 to the power 7 Newton per coulomb. Very nice, guys. I hope you guys are able to solve the questions along with me. Keep continuing that. Okay, next one. Next question says that charges plus q minus q plus q minus q are placed on the vertices of a square ABCD. So let's first draw that square. Okay, so say we have this as A, this as B, this as C, and this as D. So we have a plus q, then minus q, then plus q, and minus q charge here. Okay, and this is the center. By the way, in this case, you can see that the electric field because of these two will be 0, because of these two will be 0, and because they are equidistant, so their polarities are also just same. So the potential value at center will also be 0, because two positive charge, they are going to create potential of 2 kq by r, and two negative charge will create the same amount of potential in negative sign. So the net potential is also 0. So at O, I can say electric field is 0 and electric potential is 0 at the center of the square. Now, what does the question say? So let E be the electric field and V be the potential at center, which is 0. If the charges on A and B are interchanged with those on D and C, let's do that. If we do that, then the question is asking us what will happen to E and V. So this is O, and at A now you are replacing it with the charge on D. That means this becomes minus Q, this becomes plus Q. This minus q will become plus q, and this becomes minus q, and I think the situation you can see these are still diametrically opposite. So I would say at O still your electric field is 0, potential is 0. We can say now very easily that E and V remain unchanged. I'm sure people have already responded. You have got the answer. Very nice, guys, very nice. Keep it up. Next one. So this one says that two charges of 4 microcoulomb each are placed at the corners A and B of an equilateral triangle of side length 0.2 meters. Okay, we have to find out the electrical potential at point C. So let me draw an equilateral triangle. I'll try my best, but I'm not very good at drawings. So what you see here, say this is your charge Q, and the other charge q is placed here, and they both are at a distance r because it's an equilateral triangle. Okay, and we are talking about potential at point C. By the way, potential is a scalar quantity, so no vector rules will be applied. Don't go after applying the vector rule by thinking of parallelogram's law of vector addition. That won't work here. Remember, electric potential is like work done, so it's a scalar quantity. So if I want to find out the potential at point C, then it is nothing but kq by r plus kq by r, because both are equidistant from point C. So it is nothing but 2kq by r, and I'm simplifying it now. So this is 2, 9 into 10 to the power 9. Charge values are 4 microcoulombs, so 10 to the power minus 6. And r value is 0.2, so you can say it is 2, and you can multiply numerator by a 10. So this 2 cancel. I have 4 nines are 36 into 10 to the power 9, and this is 1, so this is 10 minus 6, that is 4. Okay, fortunately I have an answer here. That is option C. 36 into 10 to the power 4 volts is the correct answer. Okay guys, very well. Keep it up. Next question guys. This says that two equal charges Q are placed at a distance 2a. Okay, so we have two charges which are placed at a distance 2a, and okay, these are Q and Q. And then there is another charge minus 2q which is placed midway. Okay, that means the gap between these two is a, and these two is also a. Question is asking us to find out the potential energy of the system. That means total 3 charges, so all the potential energy terms are to be written. So I'll say that because of two extreme charges, the potential energy is k q q by 2a. Don't write 2a square, okay, because it's potential energy k q1 q2 by r. Then put a plus sign, that is k, first charge is q, other charge is minus 2q divided by a. Okay, that's the gap here. And then again k q minus 2q by a. Okay guys, that means I can take out kq square, or will take common after something. So this is kq square by 2a, and these two terms look similar, so that is 2 times k minus 2q square by a. Okay guys, so let's do one thing. Let's take LCM here. So I have kq square plus, and I think I should now write minus. Okay, so kq square minus this 2 also multiplies with these, so this becomes 8 kq square by 2a. So I have minus 7 kq square by 2a, which, if you will look at the options guys here, the options are looking like there's only one option which is negative first of all, and this is the only one which has 7 in the numerator, and this k will be written as 1 upon 4 pi epsilon naught. So definitely and definitely the answer is option C. Okay, so minus 7 by 2 kq square by a. Awesome, cool guys. Next one. This one says that 4 identical charges 50 microcoulomb each are placed one at each corner of a square. Okay, so we have a square again. Let me draw a square here. Okay, so you have a square with all the charges q placed on the corner, and the side length of the square is 2 meter. How much external energy is required to bring another charge of 50 microcoulomb, that means same amount of charge, is to be brought from infinity to the center of the square? Or you can say that the question is trying to ask you how much work is to be done by the external agent to bring the same charge from infinity to this point O. So you are trying to bring a charge Q here, which is going to come from infinity. So guys, in this process, what we'll try to do, we'll say that whatever is work which is done by external agent, it basically gets stored as the potential energy of the system. So we'll try to find out the final potential energy of the system, because initially the charge which is at the center was not there. So let's try to find out the separation of this charge from each and every charge. So the length of the square is 2 meters. So this becomes 1, this becomes 1. So definitely the gap of each charge is root 2. Okay, so let's try to write that energy because of the symmetry. You can say that if I'll write the energy because of one system, that is K, Q1, Q2 by R, I have to just take 4 times because all the charge systems which are being formed are symmetrical and it's a scalar quantity, so we don't have to think of vectors at all. So what we are solving is 4kq square by r, and by the way r is root 2 meters. Okay, so guys, this is 4 into 9 into 10 to the power 9. Q square is basically 2500 into 10 to the power minus 12 divided by root 2. So this is 36 into 25 upon root 2 into 10 to the power minus 1, or you can say it is 36 into 2.5 divided by root 2 joules. So when you will simplify this, the final answer will come very close to 64 joules. You'll get the answer as 64 joules. Okay, leaving you guys to do the mathematical calculations. You can rationalize as well, or you can divide it by 1.414. You should know the value of root 2. Okay, root 2 is 1.414. If ever need be, root 3 is 1.73. Actually 1.732, but you can just use 1.73, and here also you can just use as 1.4. Okay guys, okay, now time for your homework question. Everyone note this down. The question says that in the rectangle that you see here, this side is 5 centimeter and this one is 15 centimeter. You have a charge Q1 which is minus 5 microcoulomb and Q2 is 2 microcoulomb, and so it's a rectangular positioning. Question is asking you to find out the work done in moving a charge 3 microcoulomb from point B to point A. So you want to make a charge, third charge, which is 3 microcoulomb, sorry. You want to make this 3 microcoulomb charge make it move from point B to A. All I can say is that whatever is the work which will be done is the change in potential energy of the system. So earlier when charge was at B, find its potential energy with Q1 and Q2. When it reaches B, find the potential energy of it with Q1 and Q2 again. You will see there is a difference in the potential energy, and that difference is basically the work done. You don't have to bother yourself with writing the potential energy term of Q1 and Q2, reason being that is not changing, so it won't contribute in the work done. Okay guys, I hope you guys were able to solve the questions with me. Okay, if you want more questions to be solved, then there is a platform where we share those. Okay, yes, that's our Telegram group. You can come on that because there you will be getting much more like assignments. We provide study material as well as daily updates of what is happening on this channel as well. Okay, so if you are interested in joining our Telegram group as well, the link for that is available in the description. Okay guys, so if you enjoyed solving these problems with me, do hit that like button everybody, and tell your friends as well, because if you think that's going to be helpful to them, it's good to be helpful to your friends. Okay, and if you are here on the channel for the first time and haven't subscribed yet, do subscribe to the channel guys, and hit that bell icon as well, because you want to be notified with everything which is happening on this channel. Okay, cool guys, so I'll see you again very soon, and we'll continue this journey. We'll continue with the theory. More theories left in this chapter, so we'll do that. We'll continue our series of theory as well as problem solving. Okay, so remember, at 9 o'clock every day theory classes, and 8 p.m. on limited days like today you will be having your MCQ classes. Okay guys, so see you soon. Till then, keep studying, keep enjoying, keep smiling. More importantly, in this difficult time, stay safe, stay inside. Bye bye guys, take care.